Today we're looking at section 10-3 on regression, and our learning outcomes are as follows. By the end of the section we'll be able to take a set of data pairs and determine the equation of the regression line using the TI-8384 plus. We'll also be able to use the regression equation to make predictions and determine whether to use the regression equation or y bar to make our predictions. Okay, regression is the process by which we find the graph and the equation of the straight line that describes the linear relationship between the two variables when such a relationship exists. The straight line is called the regression line. The equation is called the regression equation, sometimes also called the line of best fit or the least squares line. X is the independent variable or the predictor variable, and that should be an O there. Or, see if I can get my pen tools to come up here. That's usually what happens. Okay, so this should be OR. It's called also the predictor variable or the explanatory variable. And Y is called the dependent variable or response variable. So first of all, let's do a little review from algebra. Recall that in algebra, the slope-intercept form of the equation of a line is y equals mx plus b. In this equation, what would be the slope? Okay, it would be m. The number in front of the x when we have the y isolated is the slope. The y-intercept is the b, and actually the point has two coordinates. It's 0, b. So how can we use the slope and the y-intercept to graph 3x minus 2 is equal to our y? So let me draw our y, and let me get our, let's see, I think I need to move that a little bit. So let me just erase those and start over. Okay, here's our y. And here's our x. Okay, having trouble staying straight on that. Alright, so 2, 4, negative 2, negative 4, negative 2, and negative 4. Alright, so if we think about y equals 3x minus 2, the y-intercept is 0, negative 2. And our slope, m, is 3, which as a fraction we could write as 3 over 1. And remember, slope is defined as rise over run, or vertical change over horizontal change. So 0, negative 2 is located there, and we use our slope 1, 2, 3, and over 1. You can do it again, 1, 2, 3, over 1 to get another point if you want, and then we can graph our line. Now, in terms of the textbook, the regression equation, instead of making it y equals mx plus b, they use y equals b sub 0 plus b sub 1 times x. So our slope is again the number in front of the x when the y is isolated. Our y-intercept will be the point 0, b sub 0. So in this equation, what is the slope? That would be our b sub 1. What is the y-intercept? It's the point 0, b sub 0. And we have even a different one when you get into the calculator, and we'll talk about that when we get there. Okay, as in the previous section when we had the formula for our linear correlation coefficient, b sub 1 and b sub 0 have nasty looking formulas. You can see a lot of summations in there. We're using n, the number of data pairs. We're multiplying x times y. We're summing up x and summing up y and multiplying them together. We're squaring x and adding those up. We're adding up the x's and then squaring that. So we have a lot of computation to do in order to come up with the slope if we're doing it by hand. So you can imagine if you had 100 data pairs that you were working with, or 1,000 data pairs, how time consuming that would be. Fortunately for us, we do have the calculator, and the calculator does all of the messy calculations for us. So the main thing we want to focus on here is being able to interpret what we get from the calculator. Now, in regards to round, you should round your slope and your y-intercept to 3 significant digits. If that's all they're asking for, just 3 significant digits. Now, on my math lab or my stat lab, what you want to give is whatever number of digits they ask for. Now, if you're using the equation of the regression line to make a prediction, you need to carry at least 6 significant digits on both your slope and your y-intercept. So that is kind of a point that you should be aware of, because very often I have students say to me, well, my answer is very close, it's only off by, a 100th or 200ths, and very often this is the reason. So you want to carry out at least 6 significant digits when you're using those numbers for calculations. Now, when do we use the regression equation for predictions? There are times when we use it and there are times when we don't. So what we want to do is pay attention to whether we have significant linear correlation based on our R value, and check table A6 under the alpha equals 0.05 column. So if the regression, if there is significant linear correlation, that is when we use the regression equation to make our predictions. If there is not significant linear correlation, the best predicted y value will be y bar. So what we do is we just take an average of the y values, an average of the y values. So that's if no significant linear correlation. So we'll try to do a couple of those in the exercise. Maybe we can do one where there is significant linear correlation and one where there is not. So as you can see, we don't have a whole lot extra, and actually on the calculator our slope and our y-intercept show up, and I'll point out that the equation there is a little bit different from what we have in the textbook, and it's also different from what we learned in algebra. So in terms of what variables they use to represent the slope and also the y-intercept.